So in order to flatten this file, we'll need to erase all the geometry that's not going to be covered by the paint protection film. So this would be the case for all the sensors or caps, and here any of these plastic shapes, for example. Then we should also get rid of any spikes, partial holes, and features. So we should be cleaning up our geometry until it becomes smooth as glass, with all of its edges being continuous. So we're going to get rid of all of its features as well. The software that I'm using is called VX Model, is made by Createc, which is a Canadian company as well. And well, let's get started then. I'm first going to be duplicating my mesh so I can keep a backup of the original one. And on this one, I'm going to start cleaning it up. The first thing that I'll do is to remove the things that we are not going to use. So we are going to use the selection tools over here. We can try, for example, set and change selection tool for selecting this one. And then we can increase the tolerance a little bit. And we can also make our selection larger. Right? Let's make it a little bit larger. There we go, that would do it. So now that I selected the geometry that I want to remove, I'll just remove it. And I'll repeat the process on the other side. There we go. So we could either use that one, or we can also use the brush selection, which in this case will let us select the whole circle. Remove it. For now, I'm just going to leave it there. Okay, so now that we have removed all of the features we had there, we are going to proceed and clean up the edges and sand over all the geometry. So for sanding my geometry, let me first save my file. And now we are going to go for an automated smooth mesh tool, and this one let's increase the allowed deviation. It really depends on the amount of errors that you have, which algorithm to use. Probably prismatic in this case will make a better job. This will smooth out lots of the errors that the mesh had in the first place. So I can just confirm it. If we undo and redo, we can see the change. Undo and redo. Okay. So it helped out a little bit, but we're still going to have to defeature and smooth out some parts, like for example this area over here. So for doing that, we can go for the sandpaper tool, and I always deselect the preserve features option. That will let me erase these anomalies, and I'm basically going to run this whenever I see that I have features in the surface. Right on. I'll probably keep on running it in this area. And we can always increase the strength if we feel that we're not cleaning it up quickly enough. Much better. Okay. So now that we have fixed those features that we had here in the mesh, there might be more of them, but right now I'm not seeing any. I'm going to proceed and go for, well, let's clean this one up as well. Should be cleaned up. Sometimes it's not bad idea to increase it if it's taking too much time. Being aware that we don't want to corrode the fidelity of the mesh too much. There we go. Right on. So now that we have smoothed out our mesh or removed the features that we had, then we can proceed and start cleaning up our boundaries, which this is what will take us most time throughout the entire cleanup process. So in some cases, it's a good idea to, while we are doing this, we can fill partial holes. For example, this one over here, and because they can probably affect our own selection over here. Another thing is that probably we may want to clear up this area, because if we don't want this to be covered with our PPF, then this should be removed. And I can use Control Shift for moving from selection. There we go. So basically we would need to delete that. Here we have no more choice than to do this manually. This usually takes some time. But this is important if you want your PPF to reach that specific line we have there. And we can keep on selecting. Right on. If we removed any accidental parts of the surface, we can always fill that up, either with the partial hole tool over here, or there. And once we got that ready, then yes, we can run the edit boundary tool. We can select from this point up to maybe this point, and I'm trying to select a small portion and to use a high tension there so that should do it. So I try to go for the areas that share more or less the same amount of curvature, and then I have to pay attention to the continuity between the both parts that I selected, right? So over here we have to do the same thing up to at least this area and remove what we're not going to use. In this case we could also set this to, well, maybe we can fill that in to avoid any kind of issues there. So we fill this in and we fill this in as well, and this guy. So once we got it, we'll go over here and run tool. It's much better than before. So you'll notice that when using this tool, we may get some anomalies back again there, so we'll have to clean those afterwards. In some cases like this, where we have a straight edge, if we use lots of tension, we could get rid of that issue there easily. And here the same thing, we'll get rid of that by using the same tool, so that's faster. I'm going to switch to this one, and you can see, as you can see, I'm cleaning this up thoroughly. I don't like having any kind of errors, and if I have a sharp, then I can see if I want to have either a sharp corner or something rounded. If I have something rounded, then I should be taking care of that as it is. Then we can clean it up afterwards. Oh. There we go, but we are making it run. And over here we can that would probably be better if we just clean it this way. And over here we need to take care of this as well. So I use the show boundaries option usually to display the boundaries when I'm working on this. And well, this will be better cleaned up if I'm using a good tension here, like this, and apply it, that'll do it. So I can do the same thing here. Maybe that's a lot of tension, but I can use something that's slightly smaller, and that's better overall. Much better. And we can slow this down. But that's more or less how I like to take care of it. The corners, the round corners. Here we'll have the same job, but let's go on and look for fixing this up entirely. So once we have fixed this one up, we can go for this tool again and fix and smooth out the issues that the tool may cause. So we need to clean it up entirely. So we need to avoid having any kind of deformations there and here. It needs to look good. Okay, there we go. So once we got it, we can keep on working with this tool. Maybe I'll reset my selection and probably go for a broader section here with a good tension. I'll do it. So it takes some time, but you prefer this so you can keep the fidelity of the original file there intact. Well, I can keep this as it is, doesn't hurt. So then I'm going to move forward and keep on working on it. So this looks good overall, and probably here we may want to have something smoother. But that's really, I personally don't know this specific car, but well, if we can avoid these sharp corners, that's always better overall. So here we can do the same thing. So bumpers are usually the most complex types of geometries that we're going to work with, and these usually take more time than maybe a fender to clean up. So that's good. Here on this side, apparently the part is symmetrical, so try to clean one side and see if I can mirror it afterwards. I don't know if this is intentional or not. I would probably try to fill it in, but it's really up to you. So I can fill it in kind of this way. It really depends on how this was originally designed, but then I can that's right. I should. That's how I usually take care of those kind of boundaries. You can see there is a slight error there, and we will try to get rid of it. Probably we can just select this, remove it. So our mesh needs to be perfect, basically. Right now. So over here we need to follow up this. I usually take care of the corners separately, so I prefer to go over this area first. Right. And then I'm going to clean up whatever I see that doesn't look good, like for example those small bends in the surface. I need to clear this up. It looks much better now. Then I'm going to apply my edit boundary tool over here by using the circle or algorithm. So over here this is going to be applied as well, and over here this is going to be applied as well. And we can finish back. Over here, I'll get rid of this fold in the mesh. I don't like that. That's not going to affect the pattern at all, and it basically makes the process to be a little bit more tedious. We prefer not to have such an anomaly there. I prefer, if I can clean this up, I'll do it. This is way better. Okay, so this looks much better now, and we need to get rid of that as well. Use it. Lower strength overall. Right on. And this is the last part. Here, I haven't been here with the tension tool, so I'm going to apply tension to this part, and I'm going to apply tension all over the place. If you're working with a symmetrical part like this, it really depends on if you're scanning this while it was hanging from somewhere, or if it was still, because that can cause deformations between sides. But if this was done, if this was scanned without no bending or between the both sides, I could easily run a mirroring algorithm here, but it will really depend on how VxModel detects the symmetry plane and how well it does it. If not, I'll have to make the same cleanup on the other side. So let's try it out and see what happens. So I'm going to hit OK. I'm going to save it. I'm going to duplicate the mesh, and I'm going to use this one for creating a symmetry plane. So I'm going to go to the plane tool, go to this mesh symmetry plane, and use the draw line algorithm. And this will automatically find the mirror plane of the objects, but will depend on how well it does it to see if we can use that or not. Sometimes we cannot, and we have to clean the other side. So I'm going to go now to the cut tool, and we're going to use the plane that we just drawn. And I'm going to keep both parts, and I'm going to keep this one. It's the one that I have here. There we go. So we have this one on the other side. So I'm going to take this one and mirror it by using the same plane and mirror and so. And we want to keep the original mesh. That's not this. Sorry. There we go. So if we compare this with the one that we took out, which is the one that's going to be, in this case, in gray, that means that we're good. Yeah, the symmetry plane worked very well because we don't see any deviation, any potential deviation between pieces. So that looks great. Okay, right on. So now that I have mirrored my mesh, everything looks very promising for the flattening process. So when this has been done, what I'll do over here is to take this mesh, and I'm going to duplicate it again. So I'm going to call this one mesh, or we have one per, let's call it like this, with holes, which is the one that has the holes. And I'm going to use the copy that I just did. And I'm going to call it no holes. And the reason why is because I prefer, for the flattening process, I prefer to fill in those holes overall. And I'm going to keep both of them, so I have both possibilities. So I prefer to fill in those holes. Okay. There we go. And, well, we can hit the OK button and can quickly erase this. Features. And the reason why I'm doing this is to simplify the mesh when I'm flattening it. So this will help out. And for this, let's probably work on it. bit. That should be good. There we go. Okay, that looks good. I could even use the same process as before. I could even cut this in half and repeat the process. That's something that's possible as well. I could use the same plane and duplicate it to this no holes layer, and in this one I could just trim one side and mirror it. So for example, if I have, let me clean this up a bit better, but here I could use the same operation. And the reason why I'm doing this is, as I said, is to simplify the mesh that I have here when setting this to exact flat. And I'm going to cut my mesh again if I want it to be perfectly symmetrical. I want to keep both parts, so I'm going to preview this and apply this mirroring down to mirror and so that's perfectly symmetrical. So we have one mesh with holes and one mesh with no holes, right? Basically that. So now that we have our mesh ready, both meshes ready, we can run the clean mesh command just to get rid of any weird anomalies that we may have in our meshes. That's always good before exporting. Right on. So now everything is ready. We can export both meshes. So I'm going to export this one as it is. We can call this OBJ file, and we can call this same. There we go. Right on. So once we got both files here, I'm going to go one of them. I'm going to open it up in Rhino, or you can just open up a Rhino session and import it. So it is there. And I'm going to do the same with this guy on the same session. Over here, I'm going to import it. There we go. So we have both meshes simultaneously. I'm going to rotate them in Rhino so we can have them, better precision overall. That's better. And I'm going to switch to shaded mode and perspective viewport. And let's have two layers here. One is going to be called mesh, no holes, and the other one mesh with holes. And I'm going to create one layer which is going to be called curves. And what I'm going to do now is to select the one that has the holes, to place it there, change object layer, and select this one and put it over here so everything is organized. So what I'm going to do with this one is to run the command duplicate border. Let me take this out. That should be disabled by default. Let's duplicate the borders, and I'm going to delete the boundary curve there, but then we'll have all of these curves which are going to be transferred to the flat pattern. So I'm going to change the object layer for these curves. We can make it red maybe. And I'm going to work on the mesh with no holes. So on this one, I'm going to duplicate layer and objects, and I'm going to call this one adaptive remesher. And this is just to keep a backup of the original mesh. So then I'm going to switch to the adaptive remesher layer. We have two, right? But I prefer to hide out the original one. I'm going to be working on this one instead. So what I will do now is to run the exact flats adaptive remesher. So I'm going to go to my mesh tools, go to the adaptive remesher, and select my mesh and hit enter and see what we got. So here's where we are going to see if we cleaned our mesh correctly or if we still have any kind of problems. We could leave the tolerance values by default, but I prefer to go straight forward to a lower setting now just to speed up the process a little bit, because I want my tolerances to be maybe not this low, but to be tight in order to have to preserve the fidelity of the mesh. So we can see that maybe the settings were too low, right? So we're getting a mesh that has a very high estimated vertex count. So I'm going to reduce this to, we're going to use different values here and see what we get. Okay, we're still getting a very high density for this mesh, so I'm going to hit OK, and I'm going to take a quick look at the mesh and see where the issues are. So here we can see that we got a potential issue here, and that's because, well, the polygons will concentrate in that area, and here we had other potential issues as well. So these issues will come from the original file that we had, and we can clean that up either in VX model again, or we can clean it up here. So I have to see why this happened. Well, there's kind of probably a small geometry issue. So I can always go back to VX and try to fix any kind of weird issues that we have here. This looks like a very small one, but I will still try to adjust the tension and use the sandpaper tool over here. To make sure that we are getting rid of that feature. That should probably do it. And the other error that we were having was right here over this area where I did not made probably a good cleanup. So let's run the edge tool again. Should probably fix that issue. So if this is good, then we go back to this one, and okay, this was probably there. Okay, this is what probably was now fixed. And let me see if there is something else to take care of. Probably not, so we're good. So now that we fixed this, we can repeat the process for cutting our mesh using our plane. So now we have this. We have no problems here. And bring it back. Of course, we have made some movements on our piece, but nothing that we cannot replicate again, because we used rotation tool here with that origin point. Probably let's set like that. There we go. Then like this. So let's hide this one and delete this one and bring it in again, and place it here. And one more thing they'll do is to delete the one that we had. Oh. Delete the one that we had here. So there we go. Now we're going to copy the objects layer so we can keep both. Both are the same object. Let's just save our Rhino file. Run the deformation on it again. Let's use the settings again. I'll probably have to change this tolerances again because we want our estimated vertex count to be below 2000 when we are working on a bumper, which is quite a large piece of surface with lots of complexities. We may exceed ourselves and reach something like 3000, but that would be kind of the maximum that I would like to work with. Okay, so here we just have one single issue. I can fix it in Rhino by, this is to save some time, so I can just remove this and I can make a quick fix here, creating a polyline. This is just a simple polyline with a polyline tool, and I can run the mesh polyline command. This could have been fixed there, probably it's something that you didn't saw, but I can just join them, weld them, and unify the mesh normals. This is what fixing Rhino looks like, and I'll do the same thing here. I would probably better do this in BX model, but anyway, and this was happening here again, so right there. Yeah, it was there. Probably I have to run the deformation again to see where that was. And now that we're good, this should go on wheels. Okay, so that's much better. We have got rid of that issue, and our mesh now is ready for flattening. Okay, I would probably go for a coarser setting, as I prefer not to have more than 3000 vertices in my mesh, so I can try something a little bit bigger like this and see what I get as a result. Right on. So this is much closer to what I would expect, and we can lower this down again and restart it until I get something that I like at the boundaries, but with not so many vertices here. So the reason why we need to clean our mesh very well before flattening, like this, is because we don't want the adaptive measure to actually pick up the unintentional details or issues in our mesh as if they were intentional details. So that's why I prefer to have this like that. So I'm going to flatten it now as this. So I'm going to go to I'm going to save it. I can save it as. And I'm going to run the flatter command. Flatten my mesh, I can move it aside. And with my mesh flattened in my top view, I can switch to shader mode. Now I can use the pre-flatteners and exact flat for unrolling my mesh. These are the tools that we have here. And they will basically unroll or unfold the mesh at this very first stage of the flattening process. So it's important to understand that the flattening process is a multi-stage process, and this is just the first step of the flattening process. After we run one of the pre-flatteners like this, we prepare the mesh now for the optimization process. So I'm going to go to the optimizer, which is going to be the second stage of the flattening process, and run it. And over here, under my material settings, I'm going to search for a PPF material maybe. I got the solid guard material, and I'm going to choose near isotropic. We are currently adding more materials to the exact flat library, so more PPF materials are going to be available in the upcoming exact flat updates. So I'm going to hit OK. And the linear isotropic metric that I chose is going to let exact flat understand that the material behaves in the same way in every direction. And there we go. So this chart is going to give us some useful information about what's going on with our pattern and how the strain is actually working. So now that this is triangle, let's keep it there. So the reason why I was trying to not get as many polygons as I could is because this optimizer will work better if I don't have a very large amount of polygons in my mesh. So the lower the better, as long as I'm still keeping up with the fidelity of the whole mesh. That's the other reason why I took out the holes, because that it would have taken a lot of vertices to preserve the location and shape for the holes that we had in our mesh. So that's why I am going to be applying this holes with a tracing tool. Another thing that's important to consider is that over here, it's likely for us to need a relief cut because we are going to have some sag in some areas because of the double curvature that we had there at that area. So this color coding that ExactFlat is showing us will tell us whether we might be expecting to have any kind of strain. So that means that whatever you see white, that means that you're not going to expect to have any strain there. Whenever you see cyan, that will mean that you're going to expect to have a 5% level of strain. Green will mean 10% level of strain, yellow 15%, and red 20% level of strain or more. If you happen to see any black shadowing like over here, that's going to be a representation of sag. That will basically mean that you're going to be having compression in your material instead of strain, right? So if the material is compressed, that can lead to wrinkles maybe. So we will need to get rid of some of this extra material probably in the future. So this way you can predict how the material is going to behave, so you can take some design decisions accordingly. Probably by seeing this, we may want to change over here our 3D shape. We may, for example, apply a small cut over here, so that would probably make this easier to fold over here and this easier to fold, because this double curvature area is quite aggressive for my PPF maybe, right? But in this case, I'm just going to leave it as is. Once the calculation is done, I'm going to hit OK. And now that we have flattened our piece, we can start transferring these curves that we had here that are representing our holes, shapes, and positions. So I can, for example, go for my trace tool in exact flat. Let's switch to the exact flat model and hide out the original layer that we had. So this will show us a 3D representation of what we see in the flat pattern here. So I'm going to use the trace tool, select my curves that I'm going to be tracing to my 3D shape and trace them to the part. And this will transfer them to the flat pattern. So that way we can keep intact our holes right there. So if we want to have a better look at what's going on with the strain, we can go to the Rhino options here and disable our mesh wires. And under the highlights, if we took them out, then this is going to easily show us what's going on with our pattern, where we may be expecting to have some strain or sag. So once we're good with our pattern, then we can apply other features such as, for example, piece tags. So I can call this one bumper and I can add it to the piece. And I could also add some marks like notches. So we could add tiny marks at critical spots that we may need to, for example, we could say that here there is a connection with another part, so we could mark it over here if we need to, or maybe there is a specific feature or a sharp edge that we want to mark. So this tool will let us mark any features at the boundaries. So this is going to be there in our flat pattern as well, for example. Then we can go to the grain line tool. The grain line tool is going to let us add basically an orientation for the material fiber. In this case, as we're using a paint protection film, there's not going to be weaves in the material or fiber, but this tool can mark as well the stretching direction for my material. So if I'm wrapping the material from left to right, I could mark a horizontal grain line to mark that this pattern will be wrapped in that direction. And while doing this, I could just hit OK, and that will basically transfer this grain line as a simple line in the final DXF. But if I wanted to, I could just enable this option, and this will let me forcibly add strain to my pattern piece. So as there are some PPF materials in the market that give you a better adherence when you are stretching them, with this tool, you could basically forcibly stretch your pattern. So this will shrink the pattern a little bit, so you're going to have to stretch it more when applying it. So I can add a strain of 2% that flows in the direction of the grain line. So I'm going to be stretching it in that way, in that direction. And I can also add some transfer strain. This will mean that this will shrink the pattern vertically or perpendicular to the grain line in this case. And this is going to basically shrink it that way, so you're going to have to stretch it more as well in the vertical orientation. So by doing this, if I now re-optimize my pattern piece, let's select the same PPF material that we were using before, and this is going to let us, let's wait a few seconds, recalculate a pattern, and now you'll notice that instead of having this amount of sag, probably we're going to see much more of a cyan pattern, and it will shrink a little bit from the sides. Okay, so now that we have shrunk our pattern, this will basically mark that we're going to have to stretch it a little bit more when applying it. So now that we applied our tracings, like our features here and our grain line and our notches, we can see that here in Exact Flat we have some cutting tools. So if we want to apply a basic relief cut, we can use this as well. I would always suggest doing this kind of operation to the 3D model in VX model, for example, but you could also do it here as well. So for example, if you have some issues here with this sag, you could cut a out a small triangle material there and repeat the process on the other side maybe. And by doing this, you can just remove this, and this will let you optimize your pattern accordingly, so you can leave that cut. So you can re-optimize it, but and the pattern will react accordingly. If we don't want that cut to be made out, then we can just erase the cut, and this will restore it back to its position. So now that we are good, we're going to go to our tools options, and under exact flat DXF export, here we're going to be able to export our pattern piece into any of these DXF edge types. This will basically change the way in which the DXF is built, so it will become more compatible with your cutting machine software. So depending on the cutting machine that you're using, you may prefer to choose one format or another. In this case, I'm going to build up my DXF file with splines and lines that will interpolate a smooth curve around the boundary vertices. And then over here under seam allowance, we can add some extra material to work with. In some cases, this might be useful. If you want to fold your material, for example, around, this would give you that extra material. This will offset the pattern boundary edges up to the amount that you choose over here. In the case of paint protection film, we usually don't use any kind of seam allowance, so I'm just going to leave it at 0. And the DXF text size will affect the size for the labels here, such as these piece tag or the notch tags there. So I'm going to hit OK. Once I'm done, I can go to my DXF export command, and this will export my pattern. So I'm going to go over here and export my bumper flatten DXF. Once we have exported our pattern piece, now we can re-import it back into Rhino to see how it looks like. So I'm going to go to File, Import, and I'm going to look for my bumper, flatten file, there we go. And this is the final result. So we're going to see that all the features that we just applied is going to go to a separate layer. So we see that all these layers are now embedded in the DXF file. And so this way I could assign any tool of my cutting machine for performing any of these operations. So for example, for the notches, here I could use a pen tool for marking that. Then I could assign a cutting tool for the trace lines that we have here, and for the pattern boundary as well, which is going to be in the cut layer. This is going to be the grain line, and so that would be it. Anyway, as this is a DXF file, it's going to be exported as a block object. That means that it's grouped. But for example, with any 2D CAD viewer, in this case I'm using Rhino, you could easily edit this DXF if needed. So for example, you can double click the DXF and you can click at any of these curves that we have. This is just a vector curve file, so you can do that over here in case I need to make any modifications to this. If I don't need the grain line, I could remove it. And I can also change the colors of each single feature in order to help you out when sending this to your cutting machine. So if you have any questions, don't hesitate to send us an email and we'll get back to you.